Welcome to 3.4 Gaussian Elimination. Today we are going to solve a system of equations by using Gaussian elimination. The goal of Gaussian elimination is to take a matrix, which is representing a system, and end up with three zeros in the bottom left-hand corner. Now, the reason why we do this is because when we rewrite our matrix back into a system form, we get our z variable equals a number. So that's why we want these three zeros here, because it's going to allow us to work upwards to find x, y, and z. So there are three things you are allowed to do when performing Gaussian elimination. You can switch rows, meaning you can change the position so that we do get these zeros in these positions. You can multiply a row by a number as long as it's not zero. And you can add two rows together. Most commonly, you're going to do a combination of row multiplication and row addition together. Organization is going to be key when doing Gaussian elimination. So let's go ahead and jump to example 1. First, we are going to convert the system of equations into a matrix. Now remember, you are going to want a column for x, a column for y, a column for z, and a column for your answers. So first thing I notice is I have some missing variables. Now this isn't a necessary step, but it does ensure that you are getting your matrix correct in the first place, which is you don't want to mess up on the first step. So I'm going to put 0x plus y plus 2z equals 10. And then I have x plus 2y plus 0z equals 10. And then I have 0x minus y minus z equals negative 6. So all I'm going to do is take the coefficients of these variables and the answers and plug them into my matrix. So 0, 1, 2, 10 is going to be my first row. 1, 2, 0, 10 is going to be my second row. 0, negative 1, negative 1, negative 6 is going to be my third row. Now we are going to use our legal row operations to solve by Gaussian elimination. So again, organization is so important. I always suggest making sure that this is the most organized math work you have ever done. So I'm going to just go ahead and rewrite the matrix from above in my first space. Now, remember, the goal is to have a 0, 0, 0 here. So what I notice is I have a 0 in my first row. I can move this because if I go back, one of my legal operations is row switching. So I'm going to go ahead and switch up the order of these rows first so I don't have to do too much work. I'm going to make row 1 become row 2. So let's see, row 1 is going to become row 2. And then I'm going to say row 2 is going to become row 1. And I'm just going to leave row 3 alone. So all I'm doing is switching the position. So now row 1 is going to be row 2. Row 2 is going to be row 1. And row 3 is just going to stay where it is. Remember that our goal is to have three zeros in the bottom left-hand corner. Well, I already have two of them. The only one that I need to turn into a zero is this negative 1. So what I'm going to do is I see that I have a positive 1 in row 2. Well, if I add these two together, I know that that's going to become 0. So let's go ahead and change row 3 to be row 2 plus row 3. What I always suggest before you do any addition or multiplication, the rows that you are not changing, just rewrite them. So I'm going to go ahead and rewrite exactly the same row 1 and row 2. Now I'm going to go through and add row 2 and row 3. So 0 plus 0 is going to give me 0. 1 plus negative 1 is going to give me 0. 2 plus negative 1 is going to give me 1, and 10 plus negative 6 is going to give me 4. Now that I have my 3 zeros in the bottom left-hand corner, I am done with row operations. I can move into solving. Now, I want to take my matrix and turn it back into equations. Well, this would be 0x plus 0y plus z equals 4. So I get z is equal to 4. Now I'm going to use this to plug into my second equation. My second equation should be y plus 2z equals 10. And we know the value of z is 4, so I'm just going to plug that in. I get y plus 8 equals 10, so y should equal 2. And then I'm going to move up to my first equation. I have x plus 2y equals 10. So x plus 2 times my y value of 2 is equal to 10. X plus 4 equals 10, so x equals 6. Now, just like we did with solving by substitution and elimination, you are going to write this as an ordered, not pair, but an ordered triplet. So I'm going to get 6, 2, 4. Let's go ahead and look at another example. I have the system given. So what I'm going to do first is write this as a matrix. So I have 1, minus 2, 3, and 9 is going to be my first row. Negative 1, 3, a 0, negative 4 is going to be my second row. I don't have any x's, so it's going to be 0, negative 5, negative 14, negative 23 as my third row. Now, again, I'm going to try to get 3 zeros in this bottom left-hand corner. I'm going to work with row 2 first because I can see that row 2 plus the value in row 1 would make this number 0, this entry 0. So I'm going to say I'm changing row 2 to be row 1 plus row 2. Again, as soon as you've decided what operation you're going to do, rewrite the other rows so that you do not change them. So I'm going to just rewrite row 1 and row 3 so I know that I do not mess with those. Now I'm going to go ahead and go through and do the addition. 1 plus negative 1 is going to give me 0. 3 minus 2 is going to give me 1. 3 plus 0 is going to give me 3. And 9 plus negative 4 is going to give me 5. Now that I have 2 zeros, again, my only goal is to turn this negative 5 into a 0 as well. So I don't have a 5 in that same column. So I'm going to have to do some row multiplication and some row addition together to make this value 0. Now, if I were to multiply the values in row 2 by 5, then I can add it to row 3 to make this entry 0. So what I'm going to do is I'm going to say row 3 is changing to be 5 times row 2 plus row 3. First thing I'm going to do is rewrite row 1 and row 2 so that I do not alter them while I'm going through this step of row operations. So I like to write underneath my values the multiplied version. So 0 times 5 is 0, 1 times 5 is 5, 3 times 5 is 15, and 5 times 5 is 25. Now I can go ahead and add these two rows together to get my new row 3. 0 plus 0 is 0, 5 plus negative 5 is 0, 15 plus negative 14 is 1, and 25 plus negative 23 is going to give me 2. Now I have my 3 zeros in that bottom left-hand corner. I'm going to work my way backwards to solve for x, y, and z. So I get first, z is equal to 2. Then I'm going to go ahead and write my equation for row 2, which is y plus 3z equals 5. Plugging in my z value of 2, I'm going to get y equals negative 1. Going to do the same thing for my first row, x minus 2y plus 3z equals 9. Going to plug in the two values I found. Y is negative 1 and z is 2. Do some simplification, and I'm going to solve to get x equals 1. Last step is to write this as an ordered triplet, 1, -1, 2. For example 3, I'm going to first write my matrix. My first row should be 1, 2, 3, 9. Then I get 0, 1, -1, -4. And I have 1, 4, -1, -5. So again, our goal is the 3 zeros in the bottom left-hand corner. I already have 1. The next one that I have is a 1 in this first column, but I notice if I do row 3 minus row 1, I'm going to make that first entry a 0. So let's start there. Row 3 minus row 1. So I'm going to first write my 2 rows that are not changing, and then I'm going to go through and do the subtraction. 1 minus 1 is 0. 4 minus 2 is 2. -1 minus 3 is -4. And -5 minus 9 is -14. Now I have to turn the 2 into a 0. And I know a lot of us are going to want to say, well, there's a 2 in row 1. Let's just subtract row 3 minus row 1 again. Well, yes, we could do that, and that would make this entry a 0, but be careful, because if I do that, when I do 0 minus 1, I'm going to end up with -1 in this first column, and it's going to undo the work I just did to make this first entry a 0. So what I'm going to do is I'm going to take my row 3 and I'm going to subtract 2 times row 2. And I'm going to first rewrite my 2 rows so that they do not change. And again, I like to make a small notation underneath my row when I'm doing multiplication so that I know what the multiplied values are. So I took all of the entries in row 2 and multiplied them by 2. And now let's do our subtraction. 0 minus 0 is 0. 2 minus 2 is 0. -4 minus -2 is going to give me -2. And -14 minus -8 is going to give me -6. We've reached our goal of 3 zeros in the bottom left corner, so I'm going to go through these solving steps a little quicker. I have -2z equals -6, which simplifies to z equals 3. I have y minus that z of 3 is equal to -4, so y should equal -1. And I have, with my -1 and 3 plugged in after some simplification, I get x equals 2. My final answer should be 2, -1, 3. So looking at example 4, I have my system of equations. I'm going to represent it as a matrix. And I notice that I don't have any zeros, any leading zeros. So I have to kind of start from scratch. I always like to work with the 0 in row 2 first. And I can tell if I multiply row 1 by 2, I can subtract these 2 rows from each other and get a 0 entry in that first column. So what I'm going to do is I'm going to do row 2 minus 2 times row 1. First, I'm going to write the 2 rows that aren't changing, and then I'm going to notate the row 1 multiplied by 2. So now I can do my subtraction. 2 minus 2 is 0. 1 minus -4 is going to give me 5. -3 minus 2 is going to give me -5, and 5 minus 0 is going to give me 5. Now I can see that I need to get rid of this 4. And what I can do is I can do something similar to what I did for my first row operation, but instead I can do row 3 minus 4 times row 1. First thing I'm going to do is rewrite row 1 and row 2 so that I do not alter them. Then I'm going to multiply everything in row 1 by 4 so that I can do my subtraction. And then I'm going to do 4 minus 4 is 0. -7 minus 8 is 1. 1 minus 4 is -3. And -1 minus 0 is just going to be -1. For the sake of organization, I'm just going to copy my matrix from up here down into my next matrix box. And now I have to take this 1 and turn it into a 0. And once you have 2 zeros in this first column, then you're only going to want to work with row 2 and row 3 so that you don't undo any work you've already done. So I'm going to take 5 times row 3 and subtract row 2 from it, and that's going to be my new row 3. So I'm going to leave row 1 and row 2 by themselves, leave them alone, and I'm going to multiply all of the values in row 3 by 5. So then I'm going to do 5 times row 3 minus row 2. So 0 minus 0 is 0. 5 minus 5 is 0. Negative 15 minus negative 5 is negative 10. And negative 5 minus 5 is negative 10. So now I have my 3 leading zeros. I can go into solving. I get negative 10z equals negative 10, so z equals 1. I get y equals 2 after plugging in 1 into the second equation. Using the first equation, if I plug in 2 and I plug in 1, I get x equals 3. So my final answer should be a 3, 2, 1 ordered triplet.